So we're graphing ellipses. Like I said, these are the instructions here we're going to use to find the different points. Before we start looking at examples, I'm going to go over some of the vocabulary that comes up in the lesson. Some of this might be familiar, some of it might not. First things first, an ellipse is this oval shape. It's a set of all points in a plane that are equal distant from 2 points. So this is an ellipse, and so is this. And we're going to have either horizontal or vertical ellipses. So this one would be horizontal and this one would be vertical. Then the next term is foci, or the focus points. These points right here, these are the 2 points that all the other points on the ellipse are equal distant from. So right there is the focus points, and here is the focus points. These focus points are always on the major axis, which is a word that is next, actually. Okay, major axis is the longest axis. So here is our major axis for this one. And then major axis for this one is right here. And the foci, or focus points, are on that major axis. Do you need something? Then minor axis is the shorter axis. So I'm color coding this as best I can. Minor axis and minor axis right here. And then vertices. The vertices are the 2 points on the end of the major axis. So this green, the vertices on this one. Then on this one, the endpoints of the major axis are the vertices. And then the next word is covertices. Covertices are the endpoints of the minor axis. So when we draw the ellipse later on, we're going to connect all the vertices to make the ellipse. And then, last but not least, the center, which is pretty self-explanatory. It's the midpoint here of the entire thing. Okay, so that's vocabulary. We're going to be solving for each of these points and then graphing. But for the first example, we're actually working backwards. We're finding values from the graph, and then we're going to work the other way around. So here we have an ellipse. It wants us to write the equation of this ellipse. First, we have to identify these things, and then we can fill that into the equation. So first, we have to identify whether it's horizontal or vertical. Because it's up and down long ways, it is vertical. Then the center, HK, that would be right here. That is at -3, 4. Next to ask for a squared and b squared. So a is the length from the center to the vertex. So a right here would be 1, 2, 3, 4, 5 units. So if a is 5, then a squared would be 25. And then b is the distance from the center to the outside, the shorter of the 2 lengths. So b here is 2, so b squared, b equals 2, then b squared would be 4. Okay, so now that we have these values, we have to plug them into the equation. Because it is vertical, the equation looks like this. These equations look very similar. The only difference is for horizontal, a squared comes first, and for vertical, b squared comes first. Now, what's the difference between a squared and b squared? A squared is your larger value. So if you have your larger value that comes first, then it'll be horizontal. If your larger value comes second, then it's vertical. So since it's vertical, we're going to have our smaller value first. So it'll look like this. X plus 3 squared over 4 plus y minus 4 squared over 25 equals 1. Okay, So again, A is the distance from the center to the vertex. It's like half of the major axis, and then B is always half of the minor axis. Okay, next, one thing at a time. Now we're going to go from the equation. We're going to find these points and then graph it. So here's our equation. And we're going to be using the chart the whole time with the different instructions. Okay, so first thing we need to do is figure out whether this is vertical or horizontal. It looks like a squared is first the larger value, so that means this is horizontal. So horizontal. Then we need to find a, b, and c, and then we can use that for the different equations. So a squared is 100, so that means a is 10. B squared is 36, meaning b is 6. And then c, where do they get c from? There's an equation for that. The equation right here, c squared equals a squared minus b squared. So c squared equals a squared minus b squared. So we have to plug in these values and solve for c. 100 minus 36. Right, and then c will equal 8. So a is 10, b is 6, c is 8. Because if the larger value is first, so 100 is bigger than 36, so therefore it is horizontal. Okay, so now that we have these values, we have to solve for all of this. Now center you don't really have to solve for, you're just looking for like the x plus or the y plus. Since there's nothing there, our center is at 0, 0. So this is our HK. Okay. Now for all of this, what I'm going to do is I'm going to look at the horizontal column of this graph, and it says the foci is this, vertices is this, covertices is this. I'm going to write this down. So for foci, it is h plus or minus ck. Vertices, h plus or minus ak. And h is k plus or minus b. And then major axis will be 2 times a, and minor will be 2 times b. Now all I'm going to do is plug in the values and just figure out what these points are. So h is 0, plus or minus 8, 0. So this will be plus or minus 8, 0. Okay. Now that we have all these points, I'm going to graph it on the graph and draw the ellipse. So the center is at 0, 0. So I can start there. Then the foci or focus points are at positive 8, 0 and negative 8, 0. The vertices are at negative 10, 0 and positive 10, 0. And the covertices are at 0, 6, 1, 2, 3, 4, 5, 6, and 0, negative 6, 1, 2, 3, 4, 5, 6. And then once I have the vertices, I can just graph my ellipse. What do you mean?
Like the one.
So these are the vertices that you connect for the ellipse, but what are these points? These are the focus points. These are the points that are equidistant from other points. It's also where light's refracted or something like that. So if you're planning a mission to space, you need to know those points. Okay, next one. Okay, so this one isn't quite in the format that we need right away, so we have to do something to make it into the format. Something that is important is it needs to equal 1. Both of these equations need to be equal to 1. So what we're going to do is actually divide everything by 225, which seems bizarre, but it works perfect. So we're going to divide everything by 225 to get this 1 here. And then we're going to simplify these fractions here. So 25 times 9 happens to be 225. So we're going to simplify this. So 25 divided by 25 is 1. This divided by 25 is 9. 9 and 225 divided by 9, I get 1 and 25 here.
Would we be allowed to use the calculator on this?
Yeah. Okay, then rewriting this, it would look like this. X squared over 9 plus y squared over 25 equals 1. Okay, so now I need to figure out what A, B, and C are. So wait, hold on. So the smaller number and then bigger number. So because it's a smaller number and bigger number, then it's horizontal. Wait, no, I lied. Smaller number than bigger number, vertical. Vertical. And then B squared is 9 and A squared is 25. So B is 3, A is 5. And then for C, it's A squared minus B squared equals C squared. Then to find these points, I'm using the chart again. It's a vertical ellipse, so I'm copying down these right here so I can plug everything in. So for center is going to be HK, so that'll just be 0, 0, and this is H and K. For foci, be HK plus or minus C, HK plus or minus A.
Is the vertical?
Yes. Then I plug in values. And then once I have all the values, you can graph it, starting with the center.
Are we normally going to start at the center?
For these examples, the next one you won't. Like, there'll be a different center. Okay, so same idea, same format. This time the center won't be at 0, 0. It'll be at 2, 3. We can even put that in right away. Center is at 2, 3. That's H and K. To determine whether it's vertical or horizontal, again, just looking at the chart, looks like there's a smaller number first, so B is first, so it is vertical. So B squared is 4, and A squared is 9. B equals 2, A equals 3. Okay. And then once I have all these written down, I just copied them down from the chart. I'm just going to plug in the values. And the first one for the foci is not pretty. We're just going to put that as is right here. Graph the numbers. As far as the foci goes, we aren't actually going to graph that. We could find the decimal and like eyeball it, but there's no need. We can still graph the ellipse with the other numbers. So the center is at 2, 3. Then vertices are at 2, 6, and 2, 0. Co-vertices are right here.
And you said we're not gonna do those other lower ones?
What do you mean?
Like the 2 focus ones?
No, we're not. You could do them if you want, but I don't think it's necessary.
We